Leeds International School, Form 4, First Term, Mathematics, Chapter 5, Algebraic Equations. In this chapter, you will revise and extend earlier work on the language of algebra. You will learn how to solve simple equations, solve harder linear equations, solve linear equations involving brackets and fractions. In your work on algebra, you have met the words expression, equation, and formula. They all have different meanings. We'll see what is an expression. An expression is a statement usually containing one or more algebraic symbols. As an example, x squared plus 7 divided by 4x is an expression. An equation also contains algebraic symbols and numbers, but it contains an equals sign. X squared plus 7 divided by 4x equals 3. If an equation is designed to solve a problem, then it is often called a formula. V equals IR is a formula used to calculate electrical voltage V. V equals IR normally we are used in science or physics to find the electrical voltage. Let's move to identities. You can think of equations as statements that are true for some values of the quantities involved and false for others. Some equations are true for all values of x and are called identical equations or identities. Strictly speaking, identities should be written with a special symbol like this. 2x plus 3, we call that symbol its identity. 2x plus 6. Let's move to the next topic, simple equations. Some simple algebraic equations can be solved in just one step or even by inspection. For example, if for x equals 12, you can spot by inspection that x must be 3. A more formal approach would be to divide by 4 from both sides, so that x equals 12 divided by 4 and x equals 3. We'll see another example. X plus 3 equals 5. You can spot the answer x equals 2. X equals 5 minus 3 equals 2. Although you may well be able to spot some of the solutions by inspection, it is better to solve them formally since this equips you with the skills needed for harder equations where the solution cannot be spotted by inspection. Let's see another examples. X minus 3 equals 4. You have to add 3 to both sides. X equals 4 plus 3. X equals 7. Next one, half x equals 18. Half x means x divided by 2. To solve the equation, you have to multiply both sides by 2. X equals 18 times 2 equals 36. Next example, x divided by 2 equals 4 divided by 9. Cross multiplying. Cross multiplying is a handy technique when two fractions are equal to each other. The top of one fraction gets multiplied by the bottom of the other one, and vice versa. 9 times x equals 4 times 2. 9x equals 8, and you will get the answer x equals 8 divided by 9, or 8 over 9. If you need to use the square root process, remember to allow for both positive and negative options. For example, solve the equation 4x squared equals 9. X squared equals 9 divided by 4. We can get x as square root of 9 divided by 4. So square rooting both sides, x equal 3 over 2 or minus 3 over 2. So remember to allow for both positive and negative options when you are using square root process. Harder line equations. Some equations contain many stages, not just one or two steps. You may have to recognize the equation to collect all the x terms on one side and all the numbers on the other. The like terms are then collected together and simplified before performing the final step of the solution. When recognizing the terms, you can move a term from one side of the equation to the other, but it must change its sign. Collecting like terms. Expand brackets first. Terms are separated by plus or minus. Like terms must have exactly the same letter bit. The number bit can be different. Add the coefficients of like terms. These examples show you how this works. 5x plus 3 equals 3x plus 17. First, subtract 3x from both sides. This causes the 3x to disappear from the right hand side and appear as minus 3x on the left hand side. 5x minus 3x plus 3 equals 17. When you are simplifying it, you will get 2x plus 3 equals 17. Similarly, subtract 3 from both sides. 2x equals 17 minus 3. 2x equals 14. Finally, you have to divide both sides by 2. X equals 14 divided by 2. You will get the answer x equals 7. Here is another example, this time with some minus signs. The principle is exactly the same. 3x minus 11 equals 3 minus x. First, add x to both sides. 4x minus 11 equals 3. Next, add 11 to both sides. Then 4x equals 3 plus 11. 4x equals 40. Finally, divide both sides by 4. X equals 14 divided by 4. Then you will get the answer x equals 3.5. If the overall coefficient of x looks like being negative, it may be more convenient to collect the x terms on the right hand side instead, as in this final example. 17 plus x equals 12 plus 5x. First take x from both sides. 17 equals 12 plus 4x. Next, you can take 12 from both sides. 5 equals 4x. Finally, you have to divide both sides by 4 because the coefficient of x is 4. Then you will get the final answer x equals 5 divided by 4. Equations and brackets. You may encounter brackets in an equation. It is usually a good idea to expand the brackets so that you can gather together like terms in order to solve the equation. Let's see this example. 5 within brackets 2x minus 1 minus 2 within brackets 3x plus 4 equals 3. First you have to expand the brackets. The meaning of the bracket is a multiplication. We'll expand the brackets. 5 times 2, 10x. 5 times minus 1, it's minus 5. Minus 2 times 3x minus 6x. Minus 2 times 4, it's minus 8 equals 3. Now you can take like terms in one side and the numbers the other side. 10x minus 6x minus 13 equals 3. 10x minus 6x equals 4x. So 4x equals 3 plus 13. 4x equals 16. You have to divide both sides by 4 because the coefficient of x is 4. X equals 16 divided by 4 and you can get the answer x equals 4. Equations with fractional coefficients. Some equations contain fractional coefficients. A good approach is to multiply the whole equation by a positive whole number to clear the fractions away. You would normally use the lowest common denominator of the fractions. Let's see this example. 3x divided by 5 equals x plus 1 divided by 10. First you have to find the lowest common multiple of the denominators. It means we have to find the lowest common multiple of 5 and 10. It is 10. So multiply both fractions by 10. That is the way to multiply both fractions by 10. We can cancel them out and simplify. 5 times 2, 5 times 1. 10 times 1 and 10 times 1. At last you will get the equation like 6x equals x plus 1. When you are simplifying step by step like this, 5x equals 1. To find x, you have to divide both sides by 5. X equals 1 over 5. Let's see the same example by using cross multiplying. The way to do the cross multiply is like this. It means the top of one fraction gets multiplied by the bottom of the other one and vice versa. So 10 times 3x equals 5 within brackets x plus 1. 30x equals 5x plus 5. 30x minus 5x equals 5. We have taken like terms one side and the numbers the other side. 25x is equals 5. X equals 5 divided by 25. that fraction, we can have the simplest fraction, so x equals 1 over 5. Hard examples may involve more terms. X plus 1 divided by 2 plus 3x minus 1 divided by 4 is equals 4. First, the LCM of 2 and 4 is 8. So multiply all three terms by 8. When we are multiplying it like this, we can cancel them like 2 times 4, 2 times 1. 4 times 2, 4 times 1. After that, you can have the equation 4x plus 1 plus 2, 3x minus 1 equals 32. Now you can remove the brackets. 4x plus 4 plus 6x minus 2 equals 32. You can separate like terms one side and the numbers another side. 10x plus 2 equals 32. 10x equals 32 minus 2 is equals 30. To find x, you have to divide both sides by 10. X equals 30 divided by 10 and x equals 3. It is good idea to check your answer by substitution. Summary of the lesson. An expression is a mathematical phrase such as x squared plus 4x. An equation is a mathematical sentence containing an equal sign such as x equals 4x plus 3. An equation designed for a purpose, for example, to calculate an area, is called a formula. An equation that is always true is called an identity. Simple equations may be solved by inspection. If square rooting, remember to allow for both positive and negative options. Harder equations may include several stages and possibly the expansion of brackets. With this kind of problem, you should always show each step of your working carefully. Some algebraic equations involve fractions. You can clear the fractions away by multiplying through by the lowest common denominator of the fractions. Thanks for watching the video.